All right, MEC 110, what did we learn today? Well, we did a midterm review. We went over the terms and things that are going to be on that rather easy test that we'll have next week, next Friday. Then I did a 15-minute recap video of what I showed you last week. You can see that on the same website right above this one. And then we pretty much finished up the model that we were working on, where I introduced the core tool paths and we drilled all the holes, and then I showed you area tool paths in that. Before I get to that though, I just want to reiterate on the midterm that you want to put comments on your tool paths. It is necessary to match the stock setup with what you're going to be cutting out on the machine. You know what SESO means, S-E-S-O. And when you don't use speeds and feeds, that marks you as a person who hasn't done very much machining, or a rookie. I have instructed you to choose a very careful file name, because that's the way it will be probably out there too. Mastercam is not very easy and intuitive compared to some of the other CAD programs that are out there. However, I'm going to show you later on some things it does do exceedingly well. The trihedron is this thing on the screen, and it's pointing to the positive directions. CNC machines do not know how long tools are without you telling them. G54 is the work coordinate system number 1. It's where the Cartesian coordinate system is on your part, and we also call it the origin. It is back relative to the machine 0. That's where the numbers come from. Modal means active until canceled. M01 is optional stop. MOO is stop, just in the middle of the program. M30 is stop and rewind. So those 3 things tell you how to stop. The rapid code was G00. The linear at a feed rate was G01. The circular was clockwise was G02, counterclockwise G03. The 4 motion codes. M08 means coolant on. And there will be a little extra credit question at the end for the people who have been consistently coming to class and paying attention. After that, when we finished off the part, I showed you right quickly. I better do this first. See if you can get up close to this. We're talking about our first part for the after the midterm. We're going to cut. It's going to be like a piece of swag out of 3 by 3 by 1 inch thick aluminum. Any idea that you have, I will entertain for. My idea was kind of like a paperweight for a desk, where we would cut a core shape and then engrave letters on top of it. So hey, would you please turn off the lights there? Thank you, all of them. All right, what I have here is splines drawn on a model, and I told you you can draw this model in any program you like. So that's what the solid model looks like. I brought it in, I created curve on all edges, and then I separated the levels solid and wire, and then I brought in these letters right here. So I make sure that where my drawing plane is. Then I go up here to create letters, and I say what letters I want to create. I control how big they are and their spacing over here, and then I can pick what font they were here. I went into TrueType and I picked this Magneto font, and then I chose a height of 0.1. Well, I'm going to make them 0.11, slightly bigger than they were last time. When I say OK, it says enter the starting locations. I'm going to try and center it in here like that. Now that isn't exactly where I want it, but that, if I zoom in, those letters are going to look really nice when we engrave them. So I'm happy with the size of them. Now I just want to move them. I go to X form, dynamic X form. I draw a window around the letters. I enter, and then I get this trihedron, and I can snap it anywhere I want, and then I hold on to it and I move the letters wherever I want, and then I double click again, and then they stay there, moved. Escape, escape, escape. Then I created a toolpath called contour, and I select, I changed this to a window selection tool. That's window. I draw a box around it, and then I choose a starting point. That's the starting point. And now I pick a tool, a library tool like a 1/4" chamfer mill. I make sure that it has no diameter point on the end of it. So I change this to 0, so it comes to a sharp point. I go to linking parameters and I set some kind of a depth, like maybe 0.025 thousandths, 25 thousandths. And that, I got that because I forgot of a setting. Escape. No, I don't want to save it. I'll just do it again. Well, anyway, that's how you move the letters around. I did a stock box shrunk to it before, and I need to do that before I could show you how to cut these anyway. So that's how be thinking during this week about a 3x3x1 article. If I choose your design, then the entire class will make that after they put their own engraving on it. Other than that, I showed you dynamic area toolpaths and how they work. I guess I could quickly get to that here. And the dynamic areas were over here. I need to Alt-T. And show you that dynamic area through. What we did was we selected the 2 circles and we told it was a multiple machining area. We have already drilled a clearance hole all the way through, and now instead of core working its way in from the outside, the tool will go down about halfway and then work its way out. I don't care about the circularity of these holes too much because they're just going to be clearance for some other item, I decided. And so we can watch the toolpath climb. It goes around, it goes about halfway through, and then after it gets out to the circle, it goes around again and works its way out at a 7% step over and cuts those holes really quick. Now this is 2 inches in diameter. That's 1.5 inches. Now we don't have to go in there with a drill or anything obnoxious like that. It's a little bit more elegant of a solution, and it doesn't take very much time. So I showed you that. The last thing before we get done with this is I'll show you how to break all the sharp edges. See you next week.